Okay, everybody is back, ready to go. We'll continue this now. Okay, so now we're going to be talking about the methods of deploying the hose. Okay, so we have hose rollers, which we do use quite a bit. Actually, we use the hose rollers all the time. And you can see this, like we call this a hose roller over the edge. It's edge protection. It rolls over top of this. We don't ever want to get our hose over top of anything sharp. Rigid, even rocks. Like I've even seen some where the parking lots or lots where we are. Some people put like little scuff pads under the hose at some parts where it's jagged. But definitely on top of roofs like this, you can see where they goes across, and it won't cut or mar or scratch the hose. So here's your hose roller right here. 2 people to deploy this, and you can take it on your side and you can put it up to the coupling on this 4-inch, and you pull it and you deploy it. You can pull that 4-inch hose and you can pull it. It's much easier. It's very heavy hose, 4-inch, 5-inch, whatever you're going to use. And also, you start at one and you go to the other, and it gets the water out. You'll roll the water out of the hose as well. That's how you drain the hose. Here's some hose collection. You can collect it with this machine. There's different ways to collect the hose on scenes. You got to roll it at some point to get it up. This automatic roller, they're nice. They get all the water out, very nice. It's very heavy hose. You can get it out whatever way you can. I've seen different like sit and spin things where they spin the hose around, pull the water out. Anything that works really well. Here's things again that you may or may not see on scenes. The hose bridges. I've seen them a couple times, not a lot. Like I said, if you're somewhere you don't want any cars or anything rolling over these things, this right here, you can put the hose under these things. They clamp. You open them up, and then you can drive over. It's just not very. It doesn't happen very often where you're gonna have people driving through the scenes where you actually need these. I don't know that many departments that carry too many of them, but here's some different examples of them in case you if you see them on scene, like, hey, what's that? This is so you won't damage the hose, because when you're fighting the fire, you don't want anything to happen to that hose, especially someone running over it. Same thing, that's what we're talking about, chafing blocks or the scuff pads or something like I was talking about. Chafing blocks is a simple device. You put the block over top of the hose and it just doesn't rub on things, chafing block. So what's chafing? Chafing is rubbing. So we don't want that hose to rub and maybe mar, fall apart and get damaged. Anyway, again, it kind of goes along with the skid pads or scuffing pads, as some guys call them. Old tires, whatever. That's people aren't carrying tires in their trucks, of course, like their fire trucks. But it's an example of if you have something on scene that you can put downs and you have an area that's going to damage that hose, use it. I mean, it's not going to hurt. It's only going to be. It's just safety. So do it when you can. So here's some hose straps. This is for deploying the hose as well, which you can pull it. And if you see this is for a single firefighter when he's pulling the hose. You can see this, and they got it circled, but you can see it. It's right here. It goes around his shoulder, like his right shoulder, and it hooks to that hose. So it'll hook to the hose. So once you hook it around your shoulder and you have that nozzle going, you can pull forward, and as you pull, that strap down there pulls the hose along with you. Now this is just for small hose. This is 1.5 inch, 3/4 hose. This isn't like your big 2.5 inch hose. You can do it. It's very difficult, but this is for a single firefighter at best. They'll do that. And the same thing applies for up here. So you can see going up a ladder, difficult to pull a hose up a ladder, especially when it's charged with water. So you get this strap, you can pull it as you go up the hose or up the ladder. Pull it up and you can pull it all around. And it's much easier. What types of tools are used to deploy hose? We just said hose rollers, hose straps, very easy things. Hose appliances. So hose appliances are something that we do use quite a bit. And it just depends on the scenario. This is completely scenario dependent stuff that we use, but we do have them. We have them on trucks, so we need to be familiar with them. So the hardware used with the hose, they control the flow of the water. They create pathways for water for hose layouts. So like we said, it'll control where the water goes, and it will also give you different paths for water flow. And you'll see those when we show you. The different paths that the water can flow, because sometimes you'll need more than just your 1 or 2 lines, and this just gives you more of an advantage of what you need to do. In those, you have different kinds of valves. So there's valves in these hoses and hose appliances and nozzles that will restrict the flow of water, right? That's what the valves do. And there's different kinds of valves. We've got ball valves, butterfly valves, clapper valves, and gate valves. We'll kind of go into them in a little bit, but these are different kind of valves that we have. So, your Y appliances. So these are all your valve devices. You've got your Y appliances, Siamese, water thieves, large diameter hose appliances, and your hydrant valves. So you'll see all these are all appliances. That's why they're all kind of mixed together here, but they're all good appliances, and we'll kind of go over a few of them right here. Okay, your Y appliances. Your Y appliances, the Ys and Siamese are what people get confused the most. I will tell you that. Like, it's once you get the concept, it's pretty easy. But so your Y appliances will divide one line, one single line, into two more lines. So if you've got a line coming out, you have a Y appliance on it, you can hook two hoses off and they will come out in separate directions, right? Okay, so remember that, a Y. Just think of it like that. You've got one coming in, which is my trunk, and two going out. That's your Y, right? Okay, so very simple. Now, conversely, the Siamese will combine multiple lines into one. So the Siamese is almost like this. Like you get all those lines coming into one area. So you'll have a bunch, you can have two hoses, three hoses coming into one single hose and going out. So that's the difference between a Y and a Siamese, okay? Y is one going into multiple. Siamese is multiple coming into one, okay? Your water thief, okay, is the smaller outlets that steal water from the main line. Like when the main line's coming out, these is a water thief. You hook it up and it will take water. That's your Siamese. It'll come off in different directions. Okay. Your large diameter appliances. You got a large diameter water thief, large diameter manifold. Okay. So here's your fittings, your adapters, your reducers, your elbows, your hose caps. These are all things that cause friction loss that we have on the hoses that we do apply all the time. So our adapters, when will we use our adapter? Yeah, like if we have 4-inch hose, next town over it's got 5-inch hose. So we need an adapter to fit that 4-inch to 5-inch, okay, right? And we have them. Or you got male to female, you need to adapt down. Your reducers, reducers when you go 4-inch hose. Adapters is when you go, the male to female. Your elbows, if you want to go turns, and your hose caps, just close on the front, just prevent water from going out. Okay, 5 commonly used hose appliances. We just went over all of them just now. Okay, our lays, very important, and we discuss this a lot of times as far as tactical advantages and what we're doing on a fire scene. This is our basic forward lay. I would say this is what we're going to do most of the time. Forward lay. Here's your hydrant. You're going to drop the hydrant, and that truck is going to roll forward, right? So you got someone manning the hydrant. You're going to roll forward this, and then this is your firefighting apparatus, right? Or you can supply water from this truck to another truck that is the firefighting apparatus. But this is a forward lay from the hydrant forward into the fire structure, into what you're fighting. Okay, that's a forward lay. So here's your forward lay advantages, right? The pumper can remain at the incident scene, so hose equipment and tools are available. That's why I think it's the best thing to do, and that's why it's very important. Once you lay that hose at the hydrant, you drive forward and your truck is there at the fire scene. You're right there. You can get tools, you can get whatever you need, you can get, you can control everything right there. And again, the pump operator can see the fire suppression operation and better react to changes of the fire scene. Very, very important. That engineer is there at the truck and can audibly talk to a firefighter that says, hey, I need more water, or hey, I'm not getting any water, something's wrong. We have radios, we can communicate, it's very, really good, but there's sometimes a lot of traffic on these radios, and it's hard to communicate. But if you can see the person and see the structure and you can communicate or give a thumbs up that you've got water, when that pumper operator engineer, when he gives you water, you give thumbs up like you got or you've got phone, that's great, being at that fire scene. The hydrant connection for a forward lay. All right, like I said, the communication between the driver operator and the firefighter or hydrant is essential. It's very, very important. That engineer does not want to take off down the street while that firefighter is standing there and doesn't have it wrapped on the hydrant, doesn't have it. He'll take the hose right with him. So this firefighter right here, his job is to take that hose, wrap that hydrant, I mean, that's basic stuff, and then he's gonna give that engineer the signal, okay, you can drive. He's back here watching to make sure nothing happens, that hose doesn't get caught in the back of the bed, nothing flies off, nothing rips off, nothing goes back. He's there. And when that engineer is at the fire scene, he radios back, I'm here, I'm ready for you to hook up. And then this firefighter here hooks up the hose and gets water. Engineer says like you can flow water, and when he's ready, he will flow water. Communication is essential. You have to. So, hydrant connection for forward lane. You remove the hose from the apparatus, very simple. You wrap, just like I said, you wrap that hose around the hydrant. Again, very simple. You anchor the hose, which is you will step on it, stand there, you can just make sure, but be very careful. You don't want to be on the side of it, it flips you around. And then you signal driver operator to proceed to the fire. Okay, and here's our four-way. This is a four-way hydrant connection. We don't have too many of these, but it's just something to show you so you can see where the water comes in. So this four-way hooks up, and you can see the water's coming out here when this is closed. It goes, the hydrant pressure, this is to the fire, okay? So this is to the pumping apparatus. You can have it to go to the hydrant pressure of the fire, right? And then you can have to the pumping apparatus, from the pumping apparatus, and then fire. And this, step 4, you've got water coming out to the pumping apparatus, from the pumping apparatus, and then to the fire hydrant. Or to the fire, sorry, to the fire. So we don't have many of those, but it is, that's just something to look at. Okay. Reverse light. We'll get into this. This is one of those topics that, you again, firefighting is very scenario based. You have to do with what you have. You get to a fire and all you have is a reverse lay, then you have to do reverse lay. I think there are some downsides to reverse lays, but what you do with a reverse lay is this. You pull in front of the fire structure, drop your hose there, and then the engineer will drive down to the hydrant and hook the hydrant and hook it to his truck. So, can anybody see the downsides of doing that? Some of the downsides of maybe doing that? Yeah, I mean, you're down here, fire's up here. So that engineer isn't seeing what's going on up here, isn't really communicating face to face with everybody up here. He's just taking, he's trying to get radio communication and see what's going on. I think it puts you at a tactical disadvantage, but if you have to do it, you have to do it. So again, there we go. The reverse lay disadvantages. You can delay initial fire tech because personnel must remove tools. Okay, again, that is what I'm talking about. If you're doing a reverse lay and you pull up to the fire structure, you're gonna have to, your backstepper's getting off, your captain's getting off, you're pulling tools, everything you need at the fire, you have to get off there before, and you're not simultaneously hooking up to the hydrant. So this is letting everybody off, then you're pulling the hose out the back and getting whatever you need, whatever you're ready, and then the engineer's pulling down to the hydrant. So you've done all that in wasted time, right? But before you can even get to the water source. Okay, the pump operator must stay at the water source, prevent them from performing other essential fire runs. So you're taking that engineer out of your equation essentially, because he's up the street wherever he is. Your engineer he's stuck to that hydrant, he's stuck to that truck, stuck to that hydrant. So that's where he's going to be. So it is kind of a tactical disadvantage, but it is sometimes you have what you have and you have to do it. Reverse lay with attack and supply pumpers. Okay, the first arriving pumper starts with the initial fire tech using water from its tank. The second arriving pumper will lay the supply line, connect hose to its discharge outlet, connect intake hose, and begin pumping. Okay? So, the reverse lay with 2 attack lines, like we just said. The Y. What is the Y? 1 line into 2, right? So if you drop that Y, which is a very good thing, because if your truck is down at this hydrant, a very smart tactical decision is to have your Y ready, because then you've got 2 lines. So you've got your attack line and you've got a backup if you need it, right? So that's what we need. And you can add line onto this or whatever you need, and that's important too. You need to have enough to come off the back of here, and then you're going to have enough to come off this Y to get into that structure, right? So again, this is where your engineer is, and that's where the fire is. It's a little tactical disadvantage. What is the difference between a forward lane and reverse lane? I think we just went over it quite a bit, right? One could kind of put you in a disadvantage, and one is, put you in an advantage, I think. Example of situation that require the use of a forward lane and use of a reverse lane. Forward lane is just your basic fire. That's an example right there. It's your basic fire. You go in, you see a hydrant, you hit it, you forward lay in, you're good. Reverse lay, I would say, is a fire where there's not a hydrant anywhere around except for in a cul-de-sac. Say there's a cul-de-sac and this house is like the second house on that street, and there's no hydrants up and down like a main street. So you pull in and you're gonna have to go up and get that hydrant and come back down, or leave your stuff there and go up to the hydrant and leave your truck at the top, which, again, a disadvantage. Okay, deploying pre-connected hose lines. This is advancing the Minuteman hose line. So know what you have on your truck. I can't stress that enough. Every department's had their problems where you come in, you don't know what the last crew is loaded on the truck. We now hear, which is a great idea, we have you know what load is on that truck. We have a specific load that's on that truck, so when you come in, you know, my truck has a Minuteman, or a type of a Minuteman load that we're gonna be pulling off this truck. So we all know it, we all pull it, we all get acquainted with it, and it works really, really well. And that's very important, to know what load you're pulling. This is the Minuteman. You can see how he pulls that section off his shoulder, and he's got the other head behind him. Very good load. Okay, so deployment of the hose sections. You got your flat load, you got your accordion, you got your horseshoe load. There's so many different ways to load hose. And captain of mine once told me, you load hose to unload hose. You load hose to deploy hose. So we want the best laid hose so it comes out easier, right? Because all these loads will work. All these loads will be done, but you have to be able to deploy them the right way. They have to be loaded the right way. You can't just throw it in, plop down in front of you. So just a basic flat load, one on top, and you can deploy that if it's done. And if you know what you have, you can deploy that load. If you just throw it on the ground, you get a big pile of spaghetti. It's very hard to manage. Accordion load and horseshoe load, same thing. Okay, burst hose lines. That's a very simple topic. Okay, the water pressure will decrease or water flow may stop. Well, it's gonna. If you have a hose line burst, you're gonna have water still coming out. We're gonna have to shut that line down, take the coupling off, put a new line on, and it's gonna be a pain, but it happens. Okay, two methods that can be used to deploy a pre-connected hose line. Two methods. We do the Minuteman. We just do the regular Minuteman load, and you can do a regular flat load and just pull it off. Just pull it straight off. Okay. Which type of hose loads are commonly used in your jurisdiction? We just went over it. We got that Minuteman, kind of adjusted Minuteman that we have that we pull off. We all know how to pull it. We get used to it. So that's the one you can take it to the door and you can flake it out. So we all know how to take that Minuteman load on our shoulder, take the other half, drop it down, flake it out. We want to flake it really good, and then we can go. Okay. Now we'll describe methods of advancing hose lines. Okay. Advancing hose over flat surfaces with no obstacles is easy, right? That's a very simple. We've all done it. No obstacles, a flat hose, or it's easy. You just pull it straight up. Advancing hose lines up and down stairways from standpipes, up ladders, and deep buildings is more difficult. It is what it is. Charged hose, uncharged hose. It's heavy. Charged hose is heavy. Uncharged hose is not. You can go into more places, very easy. Uncharged lines are easier to advance because they're light. You can put them wherever you want. I would stress that we don't want to take uncharged lines into any structure, but we can pull them to the structure. So you don't want to pull the flat load out in the front yard and then charge it and then try to walk it to the structure, right? I mean, that's why you take your line, flake it out, and get to the structure, and then you charge it and you go in. Again, it's often unsafe to enter buildings with uncharged lines. That's one of the first things we're taught, and that's very, very simple. Here's our working line drag. Okay, so this is a single firefighter. It looks to me that line is not charged. He's got it, maybe charged a little bit, but he's got it over his shoulder there. and it's just a working line drag. You put it over your shoulder and it doesn't have a ton of water in it. If it does, it's not much, and you just walk forward and pull. Use your body's weight, use your legs, walk forward and pull those. Very simple. Okay, so here's the safety guidelines for advancing hose line into a burning structure. You want to check that hose line and remove kinks and bends. So that doesn't just mean you're checking for kinks and bends in the front yard. That means in the hose bed and anywhere around it, because we've seen many times that hose can be all the way out flaked in the yard. Engineer gives you water and nothing's coming out, no pressure. Why? Because it's kinked in the hose bed. So it's very, very important that we get that line all the way out of the hose bed, and we're able to stretch it as good as we can and get it where we need to go. We need to open the nozzle fully to bleed the air out of the line and get adequate flow. This is what we were talking about before, about having the communication between the engineer and the firefighter. So you want to get to the structure where you're going to go before you go on. Bleed all the air out of that line and make sure you are getting water. Because if it's something you didn't see, like a kink in the hose bed or somewhere else, you may go open it up and nothing's happening. You don't want to be in the fire and be like, oh, nothing's happening. So bleed that line, make sure the water comes out, and if you're going to flow foam, you want to make sure that you let that engineer know, yes, thumbs up, we have foam. Very good. Okay. We need to select a desired pattern. If you're going fog, if you're going with straight stream, whatever you're doing, you need to know what you're going in with, and select that pattern. Position team members on the same side of the hose line. Okay, so in this picture you can see these team members are going together. You want them on the same line as the hose line. Why? Because you don't want to get tripped up and have different guys on different places. It gets very, very convoluted and close quarters when you're inside of a structure. And if you're not behind one another going down, it can be really dangerous and someone can get really hurt. Okay. So we want to check for heat using a tick, right? We always go in with a tick. Front guy's always got a tick. Sometimes some departments, their SOGs have the second guy with a tick, but we always want to go in with a tick, look for heat, or we can water spray. You stay low to avoid blocking doorways and windows. That's what children are taught. We want to get low. Smoke and areas you can't see are high. We want to get low. Keep doors closed until ready to enter, right? We want to keep control openings to limit the flow path effects, which is very, very important. So once we go, we want to control these flow paths in the smoke. So we're going to chalk the self-closing doors to prevent the door from closing and pinching the hose line. That's very important. Most of us carry like door chalks in our pockets, like door wedges and door chalks. They go up in the top of the door. They go on the hinges where you can stop that door, because some of those self-closing doors will close down and pinch on a hose. Now, most doors aren't hard enough, they don't slam hard enough or close hard enough to pinch off a line per se when you're flowing. But if the water slows, it stops, and that hose gets under it somehow, it could. But we really don't want to. We really don't. We don't really want that door to close. So it's a good idea. Just bring your chalking tools in there. It's good safety practice to assume that there is heat behind any door. Simple. Feel it. Look. Listen. Put your tick up there. We don't want to just go barging into doors. We know that from movies. We know that from TV. We know that from the academy. Just assume that there's heat behind everywhere. Okay? Be safe. Okay. So this is advancing hose up a stairway. Okay, now you can see this. You want to keep the stairs as close as possible, or as clear as possible. That is important. I've seen it many, many times where guys got stuff and they take stuff out of other rooms and everything's laying in the hallway, on a stairwell, and people are tripping on it. It's bad. So sharp bends and kinks in the hose is what we want to avoid too. So you can see this illustration here. You've got a firefighter here and two here. And I would even stress, sometimes there's one up here too until you're ready to really go in. Because you want to control these bends at each level. You want to position a firefighter at each level to control, if you have enough, if you have the manpower. You can control those bends so you don't get kinks, because you might not know a floor up or a floor down. That hose got caught in the railing or something and it's pinching off. It can absolutely happen. If possible, position the firefighter at every turn, every point of resistance. So enough. If you look at this illustration too, they go up, and do they go straight in? No. So you go up and then come back down. That is because this is the hose you're going to be taking. This is the path of least resistance and the easiest. Hose, we just talked about it. Hose is much easier to go downhill. It's grabby. You try to pull this hose up, even though he's yanking and pulling down here, it's very difficult for him to get this. If you've already got this looped up here and you're going in here, you have this whole level of hoses. You just pull and it's coming down the stairs behind you, and you can pull it right in. Not a problem. It's so much easier. You have two firefighters on the same side of the line. You go right in, you fight. It's very, very easy. Advancing down a stairway. This might be the most obvious thing that we said all day, but advancing an uncharged hose line is easier, but only recommended when the fire is minor or not present. I'm going to tell you that don't even go if it's a minor fire. If you're going into a basement fire, have a charged hose line, please. It's heavier. It's hard to carry sometimes, but you don't know what's in a basement all the time. It could be that fire could be it's just a minor fire. Until you open another door and it's full of chemicals or whatever else is going on in the basement, that minor fire turns into a major fire, and you don't have a charged hose line. Have a charged hose line. It might be more difficult and heavy. Get a couple firefighters and you can get it down the stairs. While advancing the uncharged line is easier, an uncharged line offers no protection. No protection. Let's reiterate that. If the fire conditions worsen, charged lines are recommended. No water, you can't put the fire out. Okay, advancing down the stairway. Excess hose should be stretched outside the stairway, just like up. Get the hose line wrapped around, whatever you got to do to go, and you can advance it down. It pulls much easier because there could be bends. You're going to get to the bottom of that stairwell eventually, and it's probably going to turn. Firefighters position on the stairs to feed the hose to the nozzle team. Firefighters position at corners and pinch points. This is one of my major pet peeves, is that we don't ever have enough firefighters positioned at pinch points and corners. I've been the firefighter on the nozzle, and I've been the firefighter on the pinch points, on the corners. If you are going to try to go through a residence, a structure that has a bunch of turns and bends, and you're pulling and no one is at the corners helping you go through, it's almost impossible. You have to have people stationed. It's not the most fun job on a fire, but you have to have someone stationed on those bends and corners to push that hose through the structure. You need to have enough hose to reach the fire, like we talked about earlier. Wherever you're going, you better have enough to get in. So you need to estimate however much you have on your pre-connected hose lines, 200 feet. Hey, this is 200 feet just to get to the house from this driveway, the long driveway. So if you know you've got 200 feet to get the driveway just to the front door, you're gonna need more hose. So you don't want to just pull your one line off and be stuck with that. So that's very important. The standpipe operations are high-rise packs. Every department, every district's got their own SOPs, SOGs as far as high-rise packs, hotel packs. They're usually brought in like this with a Y on them, and they'll hook to the standpipe inside the structure, inside the high-rise. Be alert for pressure relief devices on the standpipes, of course. The Gate Y can be used like we do when you hook it up right there. While connections being made, extra hose should be deployed up the stairs. Like I said, when you're hooking that up, get your extra hose then, go up and down. We will station a firefighter at that connection. We do have gauges, and that firefighter will control that water flow at this station. You have to have a firefighter stationed there. Very important. So, here's our standpipe operations, a method for connecting two attack lines to standpipe. You see this? So, they're going up, they've got the Y here, right? They've connected, and then they go up, they've got both lines, they're coming off, they're going up, they go up this thing and down, and here we go, we're in, right? Very, very, it's what we said a couple times, now you just have two. That's why we made that Y, you can have two lines hooked to your standpipe. So improvising a standpipe, I mean, yeah, you can. It's dangerous, and you're not going to come across that scenario very often. But you can improvise standpipe with an interior stairwell stretch. So this is the hose line from the apparatus. You see this? It's going up. It's connected. It's connected. It's connected. It's connected. So just a scenario that is wildly infrequent, but can happen. This is in our town, of course. So here's your improvised standpipe for the exterior. You can take it right here, and again, you pull it up to the top with you need a support to hook it onto, and here's another window where they've tied it onto too, so you can have it out. That's a makeshift standpipe. It's a very rare situation, but it can happen. Just so we know. So we're pumping, the truck's pumping that. When firefighters must improvise a standpipe system, there will be a delay in applying water to the fire. Duh, right? I mean, this is it. Like, if you're trying to set up a makeshift standpipe, imagine how long it's going to take a hose big enough to be a standpipe, you know, a 2.5, to lug it up the side of a building or up the stairwell and tying it off every level. It's going to be difficult. This delay must be considered in the planning of the overall firefighting strategy. So that means the towns that have big skyscrapers, big buildings, you know, they will have the SOGs and SLPs surrounding this, and they'll know how to do this if something happens. They've got plans in place. Advancing a hose up a ladder. This could be the most obvious one. It's easier and safer with an uncharged hose. Again, I don't like going anywhere in a fire structure with an uncharged hose. Yes, it's easier, but once you get to the top, you're not going to be able to do anything until it's charged, and sometimes when it's charged, it can be jarring and hard. A firefighter healing the ladder can feed the hose to those on a ladder. Yep. There can be someone healing. I would rather have a guy healing the ladder, heal the ladder, and have other people doing that. Only one person per ladder section. Get that straight, because I've seen 3 guys on the same section trying to get into the same window. We need 1 person per ladder section. That's just what it is. We were trying not to get hurt. The rope, hose, tools, or utility straps can be used for advancement. So that's what we're talking about. We saw that picture earlier where they had the hose strap hooked to the time. If you have a hose strap, that's an easy way. If you can get that charge line, you hook the hose line, you can do that. If you have people on the ground helping that hose get up and you've got the hose strap, you can get it almost anywhere. Okay. You don't want to exceed the rated weight capacity of the ladder. If the hose cannot be passed up the ladder without exceeding the hose limit, it should be hoisted up. Very, very simple. Know what your ladder's weight ratings are. What are the differences between advancing uncharged and charged hose lines? Oh my goodness, if you don't know that, then I feel sorry for you. One's really heavy and one is not. Okay, objective number 4, at this time let's take another break, and then we'll come back in about 10 minutes, okay?